All right, hello everybody. Mr. Malm here, and we're going to do a demo with Ms. Molsness.
Hello.
And so we're going to demonstrate Newton's third law, and to do that, we each have identical spring scales, and these can each measure forces up to 20 newtons, and they're just going to measure how hard each one of us is pulling. Oh, make sure they're in the shot. So we have these two 20 newton spring scales, and each one's just going to measure how hard we're pulling. And so if we hook these up to each other, and we both pull equally hard, what we should see is that the numbers on the scale wind up matching each other. And if we adjust our force, the numbers always match. Now, what's weird is Newton's third law says that you don't have an option. If something pulls on you, you have to pull back. And so I'm not going to pull. Ms. Molsness, you just pull. I'm not going to try to pull. I'm just trying to hold myself in place. The scale still says I'm pulling back. I don't have a choice. I have to pull back. This time, I'm going to pull. Ms. Molsness, you just hold still. You try not to pull. Do everything you can not to pull.
Okay.
And we can see once again, we both have to be pulling equally hard because Newton's third law says we don't have a choice. It doesn't matter if one of us is stronger. It doesn't matter if one of us is trying to pull. It doesn't matter if one of us is not trying to pull. We always have to push or pull equally hard. We can do a similar thing. We have this roller board here. Ms. Molsness is going to sit on this, and I'm going to pull her while I am standing on the ground with my tennis shoes stuck to the ground. And so, oops, what's going to happen here is we're going to wind up moving very, very differently. She, of course, is going to wind up rolling across the ground. I'm going to stay stuck to the ground. And yet, despite that, Newton's third law says we have to always be pulling equally hard. And so we can see no matter what I do, no matter how hard I pull, she always pulls back equally hard. It doesn't matter. Oops. She always pulls back equally hard. The numbers on the scales always stay together. It doesn't matter that one of us is moving very differently than the other. It doesn't matter that one of us is stationary. I'm just staying stuck to the ground. She's rolling. None of that matters. It doesn't matter that our masses are different. The forces always, always, always have to be the same.